censorship and plagiarism, that's definitely very important. That's probably the most important one for researchers. Collaboration, which is kind of related to that. Conflicts of interest, human subject protections. Probably most of us don't work in that area, but you never know. Mentoring, peer review, and research misconduct. So the idea is you as the student, and actually me too, are required to complete an online RCA training program provided by CITI, Collaborative Institutional Training Initiative. If you're not registered with City, you need to visit this registration information page. And I'm going to go through this with you because I actually did this myself about a week ago. Now what this is, well, so once you get to this page, you know, there's two things to do. One, you can go to this location, and I'll send you a copy of this PowerPoint. You can go to that website and actually register. And first you all look at the tutorial. Actually, we're going to go through the tutorial now because I want to make some comments about it, so let me go ahead and start. This gives you an idea how to fill this form out, how to register. Most of it's straightforward, but some of it I know would generate questions, so I figured I'll just go through it with you. So, this is not, I didn't do this, we're just on the website. It's not the most easy to go through tutorial, but basically you're going to see these little things that come up and give you some information, and this is what the site looks like. You're a new user, so you register here later on, you can just log in. So the demonstration is going to show you how to do this. It says you can pause, which I just did. So let's go to the next thing. It's so pretty easy. Click here, you're a new user. Okay. Even though, well, not all of you are Clemson students, you're doing this through Clemson, so you need to select Clemson University as the participating institution, whether you're a Clemson student or not. Later, you'll have the opportunity to register at another university if you want to register with your home institution. But as a minimum, you know, click Clemson, and it'll be a pull down menu. You'll just have to find it. Create your username and password. There's another comment I want to make there. It says you may want to use your Clemson username and password to keep things simple. Yeah, but there's a restriction there. I tried to do that because I always try to simplify the number of usernames and passwords that I have. So I used my username. When I tried to use my password, there are restrictions on what you can use as password, and I had the @ symbol in my password, and you can't do that. You can only use numbers and letters, so you might not be able to use your password. Just look at the criteria, and you may have to make up another one. So far, pretty straightforward. Just remember, register Clemson as your institution. Secondary email address. I figured this would generate questions. So here you can select whether you want continuing education credits. Don't select that. If you do, you'll have to pay $80 and you don't really need continuing education credits. So in case you don't need to do that. I suppose you can if you want, but it's not really going to benefit. And submit. Then you're going to be taken to another window where you have to enter some information. Most of it's just generic information. As far as department, just put the ECE department. Even though you may be working with a faculty member that's not an ECE, that's That's where the funding is coming from. And submit. Then you need to select your curriculum. And there are 4 things to choose. The only one you need to do is the Responsible Conduct of Research, RCR. You don't need to do any of the others that don't really apply. You don't really need to do that, just pick RCR. It's the only thing you need to do. Now, if you want to, since now you've got the opportunity to affiliate with another institution, and 6 of you, your home institution is not Clemson. You can do that if you want. I don't really know what the implications are. If your institution also has an institutional RCR program, it's possible they may have additional requirements. You may have to do something extra. I don't really know. I would probably, if you want my opinion, not bother to do that. If you're going to get involved with research at your institution later on, then you can worry about doing that. But it's up to you, but it's probably simplest just not to do that. So you go to the learner's main menu. What you'll see down here is RCR, Responsible Conduct of Research. You can see what your status is. You can enter and you can start going through the modules. And you don't have to do them all at once. And you will be given quizzes after each module. Like it's showing here, different modules haven't been completed, but I haven't actually done them myself, but I've done training like this before the Clemson setup, and this is really basic stuff. They just have to have something that proves that you actually, learned a few things. Most of the questions you could probably almost answer without the training. So you can always come back and finish later. In fact, it's probably too much to do all at once. You've got to get at least to 80 or better. But you can take it as many times as you like. Oh yes, this is probably one of the most important things. After successfully completing the course, you can print out a completion report. You not only can you must, because I need a copy of it. So you might want to copy for yourself. And the Clemson Office of Research Compliance will also keep a copy. So with that, so watch the tutorial and register for that course. You don't need to do the continuing education credit unless you really want to, but I think it costs you $80. Just go through the training sessions, pass the quizzes, are pretty straightforward. I guess maybe I shouldn't say that since I haven't taken them yet, but I'm sure there will be. Then the documentation is maintained by our Office of Research Compliance. Print out a certificate and certainly give me a copy. Since I haven't completed it either, I don't know what the options are. You could probably save the PDF version and just email it to me. But whatever, at least give me a copy sometime before the delivery is over. Any questions, let me know. I'm learning this for the first time myself. We'll probably go into it together. Any questions on any of this?
So we don't know for sure if people who've done it elsewhere, if it carries over, right?
Yeah, I'm not sure how that works. I mean, that is one motivation for maybe selecting another institution. If you're, at say NC State or whatever, and you select NC State, it may or may not give you extra things to do, but if you do it, then you will be certified at both universities. I don't know whether or not if you just did it with Clemson and then later at your own institution they wanted you to do it, if you could just transfer. But I would imagine.
So it might be worth trying. I know Sarah, for instance, has done it at NC State.
I mean, you
to log in with your, see
Okay.
if NC State is part of this program,
Okay.
and see if you can go through and add Clemson to your,
Sure, then you wouldn't have to go.
and then you could basically reprint the form since you've already done the training at NC State.
Okay, that's cool.
So that's a possibility.
That'd be a good thing to try, and if it works out, you can just do that, then let everyone know. That might make it a little worthwhile.
It's pretty common now.
Any questions? Okay, well now we're going to talk about some of these codes of ethics.
All right.
There's a laser pointer up here.
I'm not pointing that.
You're not pointing it out there.
Well, you're in charge of this. Way more than you need.
Go.
So how many people have done the RCR before? I know Sarah has. That's the only one.
See, I should have had you give that talk.
It'll be
More about the-
a single data point. You should try it and let us know since we'll know for the future if it works.
It looks like that website looks a lot different from what I was getting. So.
Yeah, we chances are we didn't join up the same group that NC State did,
Yeah.
but you know, who knows?
And I think NC State made me read all their conduct stuff too. Keep going down that.
You may have been quizzed even harder by NC State. So in the next few minutes, what I want to talk about is just the basics, sort of the guidelines behind what we would use to judge as what is ethical. Now, it's interesting, a few days ago as I ran into someone on the stairway, another physicist, and a lot of my references will go back to physicists, but I'll try to address engineers because it actually applies more in some cases to you, is that one of the physicists told me that you can't do ethics without morals. This happens to be a very devoutly religious person, so maybe there was actually some thinly veiled stab at me there, but I suspect that, you know, he might have a point, except as Dr. Harrell pointed out in his slides, these things we call ethics have to apply to all people, regardless of what we may view as right or wrong, based on our own feelings, our own morals, our own religious beliefs, whatever it is that we use as a guideline. So you'll notice first that what I've given you is a sheet, and if you go to the first page, you'll see basically a copy of the Engineer's Creed. It's a little bit more, a few more words than what Dr. Harrell presented. There's a little bit there about things that you pledge to and whatnot, almost like the Pledge of Allegiance. But you'll notice this is from 1954. And if you look through the rest of this packet, everything that you see in the rest of this packet, both the short form for IEEE, which would be the electrical engineer's version, or any of the others, you'll notice there's a lot more words, and there's a lot more text there than there are for the Creed from 1954. Now, any ideas as to why that might be? The world's a lot more complicated is one answer. But also, if you know actually a little bit about the history of the laws that we have, most laws that we have are created for a reason. Anybody know why they're created? Lawsuits, which would imply something. What would it imply? Someone did something, right? So it's kind of almost sad to see that, you know, this is just a slice. But the creeds, the rules, the guidelines that each of these groups have put in place are very long. They're not as short and simple as it was in 1954. And most of these things are there is because someone has done them. They've done these things. They've done them wrong. They violated some ethical principle. And so eventually it all had to be codified. It had to be put down in writing. And the organizations had to vote and they had to decide, what do we think is ethical? Don't do that. Okay? That doesn't necessarily mean that in your own careers that you're going to come across rules that you don't disagree with. Okay? So just as you may not all agree with the 25-mile-per-hour speed limit on campus, I know I don't, that doesn't necessarily mean we have the right to break that rule. And this applies in the laboratory, it applies in your ethics that you apply to being a professional, whether it's an engineer or a scientist, is that if you come across a rule, either from your own organization, from your university, from your employer, that you don't agree with, one ethical step that you should proceed with is not to just say, I'll just ignore it. I don't agree with it, but is to actually be proactive and try to get it changed, or to actually ask questions. And in general, for most of these things, the basic idea should always be to ask questions. If you're not sure, ask questions. If you're not sure why is this rule even here, ask a question. Don't just assume it's a stupid rule, I don't care, I'm going to put hydrofluoric acid out here, I don't think there's anything wrong with it, it's a stupid rule. Of course, that's a chemical safety rule, right, and a very dangerous one to violate, but you get the point, right? So, also, in the same vein, if you come across situations, and this shows up later when we actually sort of have you guys break up and talk about this a little bit. If you come across situations where you're not sure about whether someone is breaking a rule, so maybe it's not you and it's someone else, again, proceed cautiously, ask questions. Okay? So it's always better, part of the science and engineering, the research enterprise that you're in, we're here to ask questions. So approach it like a scientist or an engineer, right? Treat it like an experiment. I wonder why that's a rule. I guess I'm going to figure it out. I'm going to take some data. I'm going to ask people, and I'm going to see what the answer to it is, so that I will actually educate myself and I'll understand why it's a rule. Don't just approach it as in, oh God, another rule, I got to follow this one too, right? Or another thing on the RCR I got to learn, right? There must be reasons these things were put in place. There's a history behind them. There's actually sometimes very interesting history behind why some of these things are in place. Some people have done some very devious things to break rules, which actually maybe in some cases were rules that didn't exist, and that's why we have now this sort of handout. So what you'll find is, regardless of what sort of your career you go into, science, engineering, there's all the subdisciplines there, I can't even list them all, is that there exists for each field of study, a creed or a list of rules of conduct, rules of ethics, professional guidelines. Okay, so what you have in front of you is, obviously, like, as I said, the engineer's creed. You have a list, both a short form and a long form for IEEE, so that's electrical engineers. That actually happens to be the largest professional society, I believe, right? Over 300,000 members worldwide. I was hoping you wouldn't kick the physicist butt, but you did. The American Institute of Chemical Engineers, just to give you another example. Even the IT professionals, so the computer people have their own list of rules. For science in general, it's kind of interesting, and it's kind of interesting to compare them, and we will in just a second. For science, it's not as codified, but there's a reason for that, and you'll see why. And so I took one example from my own field, which I will say is the all-encompassing science, which is physics. Of course, there are other fields, chemistry and whatnot, and they also have their own guidelines. And then just as an add-on to see that this extends outside of the standards fields that you would see as science and engineering, you also have an example from professional journalists. See that they also have ethics, because if you become a successful scientist or engineer, you will be dealing with journalists. You might as well know that they are supposed to have ethics. So the Engineer's Creed, as you can see, you have a copy of it. We don't necessarily need to read it. I'm not going to read it to you, but you will need to read it, I think, to use it later on in the second half of this workshop. But you should actually notice there's a few key words here, which are sort of ones that you would obviously think should show up, right? So do something that's honest, okay? So do honest enterprise. Put service before profit. This becomes important in the field of engineering. In some ways, more so, it seems, at least, at face value, than in science. Although, as a scientist, I'm also interested in profit. Typically, it's my own profit, right? Because as a scientist, at least as an academic scientist, for example, I have to pay grad students. And I also have to get promoted and get better salaries, so my wife will let me work in the summers. Things like that. So in terms of the own profit, I also need to put service before profit in terms of actually service to my field, and not think, what can I do to get done? What can I get this done? What rules can I break to get more money? Okay? We're not supposed to do that, so that's why it's here, even in the 1954 Creed. Again, have high standards, and then especially think about the public welfare. This applies very strongly, of course, to engineering fields, because engineers build things that we all use, right? I mean, the reason that we're in this building and not worried about the upper floors collapsing on our heads, right, is because we trusted the engineers that were hired, the architects, the engineers, to design this building. We drove across bridges to come here, hoping that the bridges wouldn't collapse, right? Hoping that they did an honest job. They did not put profit before their actual service to their field, right? So that they actually were being ethical. So that's the key. Now, if you go to then The more modern version, as I said, the IEEE code now, this is sort of the short form, right? But it's still, there's a lot more text here. But again, if you look at this sort of 21st century version of this 1950s document, you'll see again echoed the same sentiments, and I just pulled the ones up there, which is highest ethical and professional conduct, right? They're basically stating up there that we're going to be ethical, we're going to be professional, we're going to be a little more specific about what we do for the public, because now it's been a long time since 1954, so not just the welfare of the public, but oh right, safety too, right? There are other concerns that we've realized over time, right? We've had things in the 1970s like the acid rain, that I remember as a kid was this scary thing that acid was going to fall from the sky. And so now they've actually codified the things that engineers need to take into account about safety. Again, you see honesty. Again, you see rejection of bribery, which basically means don't put profit before service. Okay, so these things all show up in these documents, and they're important. Now the APS, which is the American Physical Society, gives slightly different guidelines. And what you'll notice is that it actually sort of delineates what was maybe the implied job roles for a scientist versus an engineer. You notice the engineering field, you have to be careful that you don't take graft and do a bad job, right? And also that you're caring about the public. Here, more so you see that they couldn't come up with a list that was so straightforward like that, because what we're basically doing is exploratory science, whether it's physics, chemistry, biology, any one of those fields. And so we basically need to have rules which remind us to take our data and keep it in a way that we can actually look at it and show it to others. So you'll see that it actually needs to be retained for reasonable periods, and we need to be willing to share it very quickly. We shouldn't copy or falsify our data, right? So no fabrication. If we actually take that data and decide to disseminate it to the public, then we need to acknowledge who helped us with that. So that includes who are our co-authors, who worked with me on this, who actually contributed, whether it's the concept, design, the execution of the actual experiment, or whether it's an experiment or a theoretical thing, and who helped me interpret it. And there are actual gray areas there as a scientist or engineer when you go and publish as to where do you draw the line between who gets credited as authorship or who falls to the next, which is others should be acknowledged. Okay? And again, this is one where as a scientist or engineer in training, that if that's not clear to you, whether you're working in a laboratory, working for someone else, or you're the boss, that should be made clear both ways. So, and that's a very valid question to ask up front, as opposed to like, hey, can I get a paper out of this? A more valid question would be, what are your guidelines for authorship? If you're talking to, say, a principal investigator that you're going to go work for, whether it's an engineering lab or a science lab. Because those are guidelines that you may not know them, but it's also their job as a mentor to tell you what those guidelines are. Okay? So they have ethical standards, obviously, right? They're above you. And they should convey them to you, what their ethical standards are and what constitutes what would be a violation. If you go and say, hey, why don't I get authorship? And they say to you, oh, because you didn't do what I think is authorship, that should have been conveyed to you. So there's a back and forth there. And it actually falls on both of you to basically have an open line of communication. So this I think, is delineated here in the short form for the physicists, but it applies to all the fields. Obviously, physicists, chemists, biologists, scientists, and engineers, we all take money. We need to tell where we got that from. So any paper that you look at, you'll notice in the back that if we did our jobs right, we've actually acknowledged where the support came from. Whether it's a journal article or whether it's in the corner of our poster that we gave, right, we've said who gave us the money to do this research. They should be acknowledged. Obviously, you never plagiarize, but also notice that unlike in engineering, where I understand mistakes are made, right? In science, it's sort of understood that you're going to make mistakes. Not mistakes based on doing a shoddy job, not mistakes based on being unethical, but mistakes based on the fact that you're going to, at some point, have to stop your experiments and say, this is what I think is true, and I'm going to publish that, right? And I'm going to be ethical and put all the authors on it. And then later on, you may find that you're wrong. And that's exactly what you should do as a scientist or engineer, is eventually find out, that I wasn't right, that this was wrong. And you see, it's not unethical to be wrong in science, but it's certainly unethical to not then follow up on that honest error and publish either a retraction, which is, turns out we were wrong, or to publish a follow-up which says, upon further review, we've done further experiments, we see that this is no longer the case. That's how science is advanced, okay? Now, ethics, that's ethical, and it falls on you guys' head, if you go on professionally as scientists or engineers, to actually also convey that to the public, okay? The difference between those two things. Because as scientists, we're allowed to make mistakes in the search for truth, but unfortunately in the public eye, those two things aren't as sort of cut and dry, right? And we've gotten into trouble in the last decade or so with something, as you know, a typical hot topic, climate change, right? Where basically people collect data, they come to conclusions about what's going to happen with the climate, and maybe they're not always right because they're pursuing science, but then they publish retractions, they change their conclusions, science progresses, but then what does the public think? The public thinks that people are changing the data, right, to get some certain conclusion, to push politicians to do something, right? And then it falls into money, right, because you have certain corporations that don't want to tax carbon credits, et cetera, et cetera, et cetera. These things can get very complicated even in science, especially when you fold in the public and the fact that we rely on public support, okay? So it is imperative that we follow ethical standards, including the fact that it's okay to be wrong, okay? As long as we're honest about the fact that we made an error, and that error at the time looked like it was okay. Now, the final one here is peer review. This peer review is broadly defined. I mean, in science and engineering, when you go and actually put your results out there, it's essential that you get advice. So obviously journals require that you get advice, but you're not going to get something published unless you let other people read it. That's called peer review process. Other people that you don't even know will read it and give you comments. You've probably seen that done in labs that you've worked in. But it's also imperative that you ask for and receive mentoring, which is also a form of peer review. So in terms of your own ability to advance your career, get funded, etc. However, that does not imply that just because you got information in that process that you can then use that in some way that's unethical. Okay? So you may end up with privileged information. You may end up with information which is on something that someone else is working on, and your boss says, hey, take a look at this. This is a new result from this guy. Help me review this paper. That doesn't mean that you can then take that paper and then say, you know what we should do? We should take all their results and do something with them. And basically jump ahead of them or do something unethical. Basically to get competitive gain, which is the very last statement on the slide. Okay? And that could become a gray area, but it's important. Okay? Is to be ethical in that sense. Okay? So any questions about these? So these are this packet is one that you will use, I think, during our breakout session, right? I think that's what I have before we move into that. You want to take a quick break?
Yeah, maybe that'd be good.
Okay.
If anybody has any questions, you can throw them out now, otherwise we can take a break. I think we have a cooler with some water bottles back there. Anyone wants to get something to drink, and we'll come back in 5 minutes and look at some case studies and put you all to work.
We'll wake you up.